Hi, and welcome to Pre-Calculus, Chapter 1.3. The title is Shifting, Reflecting, and Stretching Graphs. Go ahead and put your first and last name and what period you're in. And so we're going to be looking at graphs today. So this is a graph of a constant function. So if you had like y equals, what is that, 4? Y equals 4. This would be the graph of y equals 4. It's just a straight horizontal line, and it passes through the y-axis at positive 4. This graph is a sloped line. It passes through 0, 0, and it goes up 1, over 1, up 1, over 1, up 1, over 1. And this one is obviously a parabola, a quadratic, and makes a nice U shape. All right. Some other common functions are a square root has this general shape that's kind of like this arc going over to the side. A cubic, meaning to the third power, has this symmetry about the origin right here. And then this is the graph of an absolute value. If you haven't used Desmos before, you could go into Desmos, type all of these functions, and you would see these same graphs. All right, so what happens when you add, subtract, multiply, or divide any of those what we call parent functions by a number or a fraction? Okay, it's going to cause the graphs to shift. All right, so if we start with the graph y equals x squared, and it's right here in this darker maroon color, what is going to happen, or how is h of x, this blue color, x squared plus 3, related to that original graph? Okay, so it looks like it shifted or moved up 3 units. So from 0, 0, it went up 1, 2, 3, which is the number that's being added. Okay, that's called a vertical shift. All right, what happens if you take the graph of x squared and within the parentheses, or within the base that's being exponentiated, you have x minus 4. So this one also has a shift. This one's a horizontal shift, and you would shift to the right. 1, 2, 3, 4, even though it says negative 4, you're moving 4 to the right. Okay, so that one's sort of the opposite. All right, so it says to compare the graph of each function with the graph of x cubed. So y equals x cubed is in this blue color. So in this bright blue is the one right here in the middle. All right, so what happens when you subtract 3 after the exponent? What happens if you add 5 before the exponent? What happens if you subtract 3 and add 4? And so let's look. Okay, so the red one, part A, is after the cube, you're going to subtract 3. So the blue shifts down. 1, 2, 3. So it has a vertical shift down. Part B is going to be green, and this one is adding 5 before the exponent. And so the blue moves 1, 2, 3, 4, 5 units to the left. And the last one in black, if you're going to have 3 right here, that's going to actually take this blue and move it 1, 2, 3 units to the right. But the 4 right here is going to move it up 4 units. 1, 2, 3, 4. So that's how you get from the blue to the black. All right. The next slide is a reflection. If you consider the x-axis to be a mirror, the result is a reflection, and all that happens here is you put the negative sign. So the negative is going to force it to open down instead of opening up. Okay. All right, if you consider the y-axis to be a mirror, the result is a fraction. So that's when you put the negative sign under the radical. So the original or the parent graph is the blue part. And then if you squeeze in a negative, it's going to reflect it over the y-axis in this case. Okay? So these are all non-rigid transformations, just basically meaning that they're stretching them. They're either having a shift or a stretch. Okay? So the parent function on this one is it looks like the burgundy, this darker purple color right here. So that's the absolute value of x. So what does multiplying each of them? So if you multiply the absolute value of x by 3, it turns it to this blue graph, which is actually skinnier. Okay, shrinks it in this way. And if you multiply the absolute value of x by 1/3, it goes from the purple out to the red, actually expanding it. Okay.